Okay, we're starting a new unit today. This unit is looking at fatigue, recovery, and injury. There's 3 parts, but within this video, we're going to go over understanding fatigue, what it is, and how it's caused. Now, fatigue is quite a complex construct, and that's because it's multifactorial. There's many things that influence fatigue, whether that be the mind or the body. A definition for fatigue is a reduction in the ability to produce force or power, so you can use that definition moving forward. But like I said before, it can originate at different levels. So we can have central fatigue, which you might have originally thought of as mental fatigue. This type of fatigue originates in the brain and the spinal cord through the central nervous system. So central fatigue, think central nervous system, brain and spinal cord. And then we can also have peripheral fatigue. So peripheral fatigue is on the periphery of our body. It is talking about fatigue at the muscle level. So be that the muscle itself or the neuromuscular junction between the neuron and the muscle, where that message gets sent from the nervous system to the muscular system, or within our energy systems as well. This would be peripheral fatigue. So if you think about a time when you felt fatigued, maybe it's your body that's given up, but your mind wants to keep pushing and you can't physically get your body to do what you want it to do. Or a different time where it's your head that's given up more than your body. So your body wants to move, but within your mind, within that central nervous system, you're just fatigued and you can't get the message from your brain to your muscles. Okay, so let's talk a little bit more about central fatigue. So central fatigue, it occurs in the brain and spinal cord. We think about the central nervous system. So it affects the ability to activate and control muscles during exercise. So we've got this issue with the nervous system. The muscles themselves aren't physically exhausted. It's just our brain and our spinal cord not sending that message across so that our muscles do what they need to do. So when we're exercising, especially during prolonged or intense exercise sessions, our central nervous system can become less effective at sending signals to the muscles, and that can reduce muscle activation, it can reduce coordination, it can reduce our reaction time, even if our muscles still have the capacity to work. So it's linked to motivation. Central fatigue is very much linked to mental drive. So when motivation drops, whether that's due to stress or boredom or lack of sleep, our brain will become less willing to push our body. It can be linked to nerve signal transmission. So the brain sends signals through the spinal cord and then across to the body to activate muscles. But when we're fatigued, this signal strength can weaken and reduce the muscle's ability to contract forcefully or consistently. And then it can also be linked to neurotransmitter levels. So our exercise capacity can change depending on the balance of neurochemicals that we have, or neurotransmitters that we have available, things like dopamine and serotonin, also acetylcholine as well, which we know is essential for muscle contraction. Okay, if we think about peripheral fatigue, this one occurs at the neuromuscular junction, like I said before, or within the muscle. So it's on the periphery. It occurs outside of the central nervous system. So in terms of how it relates to exercise, so again, during prolonged, intense exercise, our muscles can become chemically and physically stressed, making them less responsive to these nerve signals and less responsive to actually contracting. So we have a drop in the force of contraction, we have slower contractions, and eventually the inability to continue exercising. So in terms of chemically stressed, what I mean by that is changes in the pH level. So I know when I exercise, when I start exercising anaerobically, I'm going to start building up that lactic acid, and eventually that lactic acid, along with hydrogen, is going to decrease the pH level within the muscle, making it more acidic, which leads to fatigue. I can also have dehydration and electrolyte imbalances. So when we're exercising and we're sweating, we're not only losing water, but we're losing electrolytes as well. And the electrolytes we're going to be concerned with are mainly sodium and potassium, and calcium a little bit as well. And then, of course, our last cause of peripheral fatigue is low fuel. So we depleted our glucose and our glycogen stores. We've used up all the available glucose within the cell. I've even broken down the stored glycogen within my muscles and turned that into glucose and burnt through that as well. So when these energy sources start to run low, our muscles can't contract efficiently, leading to fatigue and a drop in performance. Okay, so to talk about electrolytes a little bit more, like I said before, sodium and potassium, these two electrolytes are really, really important for our nerve signaling. And we also know calcium is super important for muscle contraction as well. So sodium and potassium, how do they relate to exercise and muscle contraction? These two electrolytes create the electrical gradient across your nerves. They're basically allowing the message to go from the brain and from the motor neuron to the muscle. So when we generate a nerve impulse or an action potential, we need this rapid shift of sodium coming in and potassium coming out of the neuron for it to fire and for it to send that message down. So they're transporting the message through the neuron until it gets to the muscle. The signal or the action potential will travel down the neuron until it gets to our muscles to tell our muscles to contract now, and it does that through the neurotransmitter acetylcholine. So when we sweat, we lose sodium and potassium, and when we lose sodium and potassium, these nerve impulses slow down and fail. Now, we not only lose sodium potassium through sweating and dehydration, we also lose sodium potassium through diuresis, and diuresis is peeing. Now, at altitude, we increase diuresis, and that can further exacerbate the loss of sodium and potassium. So hydration and electrolytes are super, super important at all times, but especially at altitude, because we have this increased diuresis that throws off our levels of sodium and potassium even more. So a little demonstration to show you. The white lights that you can see traveling down the neurons here are the action potential, or the message that you're sending from the brain to the muscle for it to contract. Now, as you can see, the white lights follow this pathway from one neuron to the next and eventually to the muscle. Now, for that white light to continue moving down that neuron, that's where we need sodium and potassium. So they sort of push along that signal until it reaches the muscle. So if we didn't have enough sodium and potassium, that message might get stuck or might transmit very slowly from one neuron to the next and reach the muscle very late. Okay, calcium is another electrolyte, and we need it for muscle contraction. It's not as important as sodium and potassium, and I'll explain that in a second, but we know the role of calcium for muscle contraction already. It's released from the sarcoplasmic reticulum when that nerve signal arrives. So the nerve signal arrives at the muscle, it gives its acetylcholine to the muscle. That acetylcholine triggers calcium to be released from the sarcoplasmic reticulum, and then calcium within the muscle fiber binds to troponin, which moves the tropomyosin out of place and allows actin and myosin to bind together and shorten the sarcomere, therefore shorten the muscle. Now, without enough calcium, your muscles won't contract properly, or they'll contract very weakly. Now, why it's not as important as sodium and potassium is because the calcium within the sarcoplasmic reticulum, the calcium within the muscle, it's not quite related to the calcium that we eat or ingest. The calcium within the muscle is actually released from the sarcoplasmic reticulum and then reabsorbed by the sarcoplasmic reticulum. So it stays within the muscle. We can't exactly top it up by having, an electrolyte drink. But there are things that will affect the release of the calcium from the sarcoplasmic reticulum, which will be important later on. Now, a quick recap of what calcium does in the cell. So you can see those little red dots of calcium flooding into the muscle cell. They're going to bind to the little yellow troponin. This binding of those two molecules will cause the troponin to change shape and move the tropomyosin away from the binding sites on the actin, allowing the head of the myosin to attach to the actin and perform its power stroke and shorten the sarcomere. Now, another important thing to consider when we talk about fatigue is altitude. Altitude and fatigue have a very influential relationship on one another. Altitude leads to very high risk for fatigue, and there's a few reasons why. So main one is we know that oxygen is lower when we're at altitude. So because there's less oxygen in the air, when we exercise, we're going to rely more on our anaerobic systems. And remember, our anaerobic systems are what create the byproduct of lactic acid. So if we're relying more on our anaerobic energy systems, we're going to have increased lactic acid buildup, which will lower the pH within the cell, so making it more acidic and therefore making it harder for the sarcoplasmic reticulum to manage that reabsorption of calcium. So that is how it leads to quicker fatigue. We also see at altitude that our body loses more fluid. Like I said, you have increased diuresis. So when we're going to the toilet more, we're flushing out more sodium and potassium and calcium, meaning that we've got less electrolytes to be able to transmit those nerve signals and contract the muscle. So fatigue is extremely high risk at altitude, and we're going to talk about some strategies later on in this unit of how to manage fatigue and how to recover properly, especially at altitude. Okay, so a quick recap on the sources of fatigue. So the central nervous system, again, it's the brain and spinal cord. It leads to fatigue through decreased neural drive. So those neurons just aren't firing as effectively as they once were, and decreased motivation as well. And then we have peripheral fatigue. So an overview of peripheral fatigue, it's happening more at the muscle and the neuromuscular junction. It's related to changes in pH, changes in hydration, and the availability of fuel. So when these things are out of whack, we have a decreased force of muscle contraction and increased fatigue substances like lactic acid that are floating around within the muscle cell. Two important things to remember as well for peripheral fatigue is electrolyte loss. So when we sweat, when we go to the toilet, we lose electrolytes, which can result in muscle contraction failure. And at altitude as well, remember there's less oxygen, which means we're going to have increased anaerobic fatigue due to the buildup of lactic acid.